Hey guys, so we are actually in day 9 of Unit 6. I'm so proud of you. You're doing great. So we're going to keep going with some U substitution, but then we're going to do it now with this new rule of an ln, and then we're also going to see some other techniques. Okay? So the first thing we're going to learn about is, do you remember way back when we learned about the power rule for antiderivatives, and we said there's one power we can't take, and that's when x was to the -1. Because if I do that, I get this, which is, oh no, ah, okay, there, ah, okay, so we cannot have that. It needed its own special rule. And in fact, when I have this, it is called the ln rule. So the derivative um, of ln of x, if you remember, is 1 over x. So the antiderivative of 1 over x is ln of x, which, with a little bit of a hiccup, it's the absolute value of x, okay? So we got to be careful on that. And then, of course, plus c, the constant of integration. So, and then don't forget that the coefficients go along for the ride. Woo! Okay? So we're going to go look and see how this works with some U sub or even just in general. All right, so this one right here, I can rewrite to just get it like coefficient and then 1 over x. So this is 4, and then the antiderivative of 1 over x is the ln of the absolute value of x plus c. Now, the only difference is on a multiple choice, you may see it a little bit different. Because remember, in ln rules, the coefficient could go up to the exponent, and then if I have something to the 4th, I don't need absolute values because I know that guarantees positive anyway. So don't forget those ln rules on multiple choice. Okay, let's look at number 2. This one's not as easy, so I'm going to do a U sub. I see my du is 3 dx, so I'm going to bring over my 1/3. So now I've got the integral of 1/3, 1 over u, du. Coefficient goes along for the ride. The antiderivative of 1 over u is the ln of the absolute value of u plus c. Then I'm going to go ahead and put what the u was into the absolute values. Okay? Let's look at the next one. This looks all over the place, so I'm going to say, oh, if I look at the top, that looks good because it's a degree difference of 1, so I a lot of times think the u is that one bigger degree. So let's go see what happens, if it will work out or not. So can I get this to equal x squared plus 2x dx? Well, if I take out a 3, I actually get just that. So I can rewrite this as the 1/3, 1 over u, du. Can you believe that? Just through a u sub, I can get now this antiderivative and go back and plug in what the u was. Beautiful. Okay, so we had learned that we could memorize cotan, but I want to show you where it comes from. Same as tan. So cotan is the cosine of x over the sine of x. And remember, if I have to pick one of these to be u, I always want to pick the denominator. And look at how beautiful this happens. What's the derivative of sine? Well, it is cosine. So I can see that this becomes du over u, or if you like to see it like the 1 over u du, which is the ln of the absolute value of u plus c, the ln of the absolute value of sine x plus c. So we had to memorize that formula earlier, but if you ever want to just know cotan and tan with u sub, here you go. Here, let's look at this next one. Okay, so a lot of times people think I'm going to pick my u to be the 2x. So don't write this down. I'm just going to show you because you're like, oh, that means it's wrong. So if I pick my u to be the 2x, I have e to the u over 1 plus e to the u du. That doesn't help me. I can't figure out what to do here, okay? So this one, that 2x is not my u. What is my u is the entire denominator. So my u is going to be the 1 plus e to the 2x. And let's see why that happens. When I take my derivative, the 1 goes to 0, the e stays the same times the derivative of that, which is 2, and of course the dx. So I can bring the 1/2 over, and I have exactly what I needed left. So this is 1/2, 1 over u du. Isn't that cool? So 1/2 now the ln of the absolute value of u plus c, which is 1/2 the ln. And notice how I don't have to put absolute values anymore because that n side is always positive anyway, so it's a redundancy. You won't be counted wrong if you put them in, but you just don't need them anymore. Okay, so the next thing I want to go over is the review of long division and how we're going to need that for integrals. So let's say that I had something like this. Let's remember how to do long division. So I put the denominator on the outside, and then I put the numerator on the inside of that division. And if I have anywhere I've skipped a degree in order, I'm going to put a 0 in. Okay, well, you don't have to, but you can. So then I say, well, what do I need to multiply 2x by to get to x squared? Well, I definitely need to multiply by an x, but I need the coefficient to be 1, so I'm going to have to multiply by a 1/2. So now I take that and I distribute to both. So that would be an x squared minus an x. Then I subtract everything in here. So x squared minus x squared is 0, which it should be, or we did something wrong. Negative 2x minus an x would be negative 2x plus x. Okay. Oops. Yeah, plus x. Oh, I did that wrong over there. I'm so sorry, you guys. Okay, so let me finish this off, though. Make sure. Dang it. Okay, I gotta fix my notes. But, okay, so plus x, which would be a negative x. Okay? So then I have to say, what do I need to multiply 2x by to get negative x? Well, now I have to multiply it just by a negative 1/2. I'm going to distribute to both. So that would be a negative x plus 1, and then subtract. So those guys cancel, and I'm left with negative 1. So I'm going to put plus a negative 1 over what that denominator is. Okay, let's try the next one. 3x minus 3, and we're going to divide it into 3x cubed minus x plus 9. So what do I need to multiply the 3x by to get 3x cubed? Well, I don't have to do anything because 3 and 3 is already there with that coefficient, but I do have to multiply the x by x squared to get to x cubed. So I'm going to put 3x cubed, I've got to take it to both, so make sure we distribute, minus 3x squared, and then I subtract. And this is why some people like to put that you didn't have any x squares and then bring out that minus x plus 9 so that it's easier to line everything up. Okay, so now those guys cancel, which rightly they should. This becomes now a 3x squared, and then those drop down. I didn't have anything else to subtract. Now I can see I need to multiply 3 and 3. Whew, that's nice. so I need to multiply by an x. So this becomes 3x squared minus 3x. And then I subtract. Those guys cancel. Negative x plus 3x is a positive 2x plus 9. Now this one's kind of gross. This one I need to multiply by a 2/3 by that 3 in order to get to the 2, and I don't need to multiply any more x's. So we can see this is going to be our last one. So here I get 2x minus 2, subtract that, and I get 11. So now this would be plus 11 over 3x minus 3. Okay, so you're saying, why did we just have to review long division, Mrs. Whitmer? Because you're going to have integrals where you have to do long division first. So if in the integral down in the denominator degree versus the numerator degree, if the denominator is bigger, then we typically do a u sub. But if the numerator is bigger or the same degree, we have to do long division when that numerator is bigger or the same. So here I can see that this numerator is a bigger degree or the same, in this case it's bigger, than the denominator. So I have to do a long division first. So I need to multiply and say, what, 6x minus 3. And so now I can see that this integral actually becomes 6x minus 3 plus 3 over 2x plus 1 dx. Now that I have that, I'm going to say this first part is an easy power rule. Then I have over here where I'm going to do a u sub. So this is just 6x squared over 2 minus 3x plus c. And you can put the c here or just wait, doesn't matter. But over here, I have to go do my u sub. So then I put them all together to get to my answer. So now I can pick that my answer is C. Okay? I would like you guys to try the next one. See if you get the long division all by yourself. Pause me if you need more time. Okay? Oh shoot, this is a typo. That's supposed to be a 2, and here you were just doing it all by yourself. I'm so sorry. Okay, that was supposed to be a 2. That was a typo. Now go try it. Should make your life easier though. Okay, so when you're ready, unpause. Oh my gosh, look how nice and easy that was. Okay, so this is actually the integral of x plus, and I can get rid of a 2 here, which is nice. 2 over x minus 1. Now go finish and see if you can get the right answer. Okay. Okay, And then the last thing we're going to talk about are inverse trig rules. So inverse trig rules you need to memorize. So these are your last antiderivative rules that you will need to get memorized. Lots, I know, but get your flashcards going. But now I can see A is some number and U is some function of x going on, okay? When I have the function of x squared and I have the derivative up above with the radical of some number, and we can always square root it to get the square, okay? Minus the u squared, this is arcsine. Arcsine is the only one that doesn't have the coefficient of 1 over a in front. When I don't have the radical and I have a plus, this is arctan. When I have the radical and the function and the a are switched, and I also have a u out in front, it is the arcsecant. On the inside, they all have u over a, but the arcsecant is the absolute value. So let's go try some. Number 1. Here I can see, first thing I do is I rewrite as the 4 squared, and then this one is an x squared. If that is my u, the derivative is just 1 dx, which I can see I clearly have. This is set up perfectly for the arcsine. The arcsine does not have a 1 over a, but on the inside, it is the u over the a plus the c. Excuse me. Number 2. I'm going to rewrite. This is radical 10 squared plus 5x squared. And I just put the dx over there. So when I see this, I can see that my u is 5x, the derivative is 5dx. I only have a 1. So I have to go manipulate by multiplying this by a 5. But I can't just throw in a 5. I can always multiply by 1. So I'm also going to put a 1/5 on the outside to balance, because 1/5 times 5 is 1, so I haven't hurt anything. So now I have this set up where I can go take my arctan. 1/5 goes along for the ride. Arctan is 1 over a. Then I do the arctan of u over a, and then plus c. Then you can simplify as much as you want. So this 1/5 was from getting, like, basically this to be the derivative of what was up there. Okay, let's look at number 3. When I look at this, I need to do a lot of rewriting. I always start with the inside of the square root. I can see that this is a 4x squared squared minus 1 squared is 1. Okay? The 5/3 seem very needless to me, so I'm going to go ahead and take them out. And then I still had the x. So this is where I started. Oops, and I still had the dx. I guess I should have put that. This is kind of where I'm starting. Now I need to say, what do I need to manipulate? So if this is my u, the derivative of this is 8x dx. So I need to make sure I have an 8 here, which means I also have to have a 1/8. Variables cannot go on the outside. So if I put an x here, it has to go on the inside, which would be the x over x. Then I can also see that this needs to be the same as this. So I also need a 4 here, which means I need a 4 on the top. Now I am set up all here to do an arcsecant. So my coefficient, which we can simplify as what? 5 over 6 is going to go along for the ride. Arcsecant is 1 over a, but my a is just 1. Then I do my arcsecant. This one is an absolute value, which I don't really need because it's a square, over my a plus c. So this would be 5, 6 arcsecant of 4x squared plus c. So one last concept that we're going to talk about is completing the square in order to get a lot of times the arctan in the denominator. So this is one more review. So when we complete the square, we're always going to factor out if we had a coefficient from the first two terms. Then I'm going to do my b divided by 2 and square it to get the term I need on this inside. So in this case, that would be negative 6 divided by 2 squared is 3 squared, which is 9, or negative 3 squared quantity. So I know I need a 9. So I also have to do a minus 9 to balance it, and then I'm going to multiply it by whatever that coefficient was and take it to the outside. Now I can write that as a perfect square. That is the goal, that I combine these two to the outside. So this is an Algebra 2 concept. If you need more help, then we can practice together. Let's go see how we need to see it. So here, I'm first going to just look at this and rewrite. This is negative x squared minus 4x plus 12. I cannot do a u sub here because the derivative of a square needs an x. So I'm going to look at this guy on the inside and try to get it to a perfect square. I'm going to take out the negative from the first two. I'm going to take my b, divide by 2, and square it to get what I need here. I'm going to take this last term and bring it out. So that would be plus a 4 plus a 12 after I distributed the negative. Now I can rewrite this as a perfect square. Okay, I did that. So now when I come over here, and I'm going to just flip-flop the order now inside my radical, that is a 16 minus an x plus 2 squared, and I left off my dx. Why did we do that? Well, now I can see that this is an arcsine. This is my u. My du is just 1 dx. So I can take that 8 on the outside. My a was the 4 squared, and there was my u as the x plus 2 squared. Now we have it set up for an arcsine. The coefficient goes along for the ride. Arcsine does not have a 1 over a. Oops, arcsine. Then I do my u over my a plus c. Okay, here is an easier one where you first need to complete the square. What makes this one so nice is there was nothing really to factor out. So I can do my 4 over 2, my b over 2 squared. See, I get plus 4. Take that out, there was nothing to distribute. So now this perfect square minus 4. Rewrite my integral. Here, the derivative is just a 1. So I'm going to take that coefficient out in front that we had from the beginning. Coefficient goes along for the ride. This is an arctan, so I need a 1 over a. Arctan of u over a plus c. So cleaning it up, I get 2 arctan x plus 2 over 2 plus c. Okay, one more that I just wanted to talk about is if you have just the x minus a number, instead of doing long division, you could do synthetic division and see how we have to do either long division or something because it's bigger or the same. So when you do synthetic division, just wanted to remind you, the 3 drops down, multiply, add, multiply, add. So now this is 3x minus 4 plus 9 over the x plus 2 in our integral. Go ahead and take the antiderivative. Evaluate from -1 to 1 and see if you get C. Okay, so I know that that was a longer day, a lot of things going on, and yeah. But we finished Unit 6. Good job.